A beam of light fires from a Navy destroyer into the dark. That is not a movie. That is the USS Preble, firing a high-energy laser at a drone last year. Right now, the United States military is spending $3 to $4 million per missile to destroy drones that cost $20,000 to build, dozens of times a week. The math is not just bad. It is historically, spectacularly bad. Lasers should fix all of it. Speed of light engagement, pennies per shot, no ammunition to run out of. On paper, directed energy is the most obvious upgrade in the history of warfare. So obvious that people have been saying exactly that for 40 years. In 1983, Ronald Reagan announced the Strategic Defense Initiative, space-based lasers to shoot down Soviet nuclear missiles. Billions of dollars later, zero operational weapons. The Navy tried chemical lasers in the 1980s. They worked. They also used chemicals so hazardous that putting them on a ship was essentially volunteering the crew for a different kind of combat. For decades, the pattern held. Lasers worked in the lab, they failed in the field. Every few years, someone would promise they were 5 years away. Then 5 years would pass, and someone would promise they were 5 years away again. But something changed. And the reason has less to do with the laser itself and everything to do with what's coming at the ships that carry them. Stay with me, because the answer to why lasers aren't everywhere is not what you think. It's not money. It's not technology. It's something much harder to solve. In 2014, the Navy deployed the Laser Weapons System, or LAWS, on the USS Ponce in the Persian Gulf. First time a laser went to sea as an authorized weapon, and its origin story is humbling. The Navy's first operational laser weapon was, and I cannot stress this enough, 6 industrial welding lasers bolted to a warship. That's not a weapons program. That's a home depot run with a security clearance. But it worked. 30 kilowatts, 59 cents per shot. It burned through drone wings in 2 seconds, cooked boat engines in a few more, and detonated rocket-propelled grenades on command. Sailors compared its optics to having the Hubble Space Telescope at sea. LAWS proved the concept. HELIOS was built to make it real. Lockheed Martin won a $150 million contract in 2018 to build a 60-kilowatt laser permanently integrated into a destroyer's Aegis combat system. Not bolted on as an experiment, wired in. Able to track, target, and fire using the same architecture that controls the ship's missiles. HELIOS uses spectral beam combining. Multiple fiber lasers merge into a single coherent beam with higher quality and longer range than LAWS ever achieved. It can dazzle sensors at low power or destroy targets at full output. In 2024, the Preble used it to shoot down 4 drones in live testing. But here is where the engineering gets honest. A laser beam is light, and light has to travel through atmosphere. Rain scatters it. Fog absorbs it. Humidity causes thermal blooming, where the beam heats the air in its path, creating a lens effect that defocuses the energy before it arrives. A 60-kilowatt laser in clear desert air at 2 kilometers is a different weapon than the same laser in North Atlantic fog at 5. Then there's the electricity problem. The newest Arleigh Burke Flight 3 destroyers already use most of their power running the Spy 6 radar. A rear admiral publicly said the Navy would need to remove existing systems or pursue very aggressive power management just to run one 60-kilowatt laser. Imagine buying the most advanced warship on Earth and being told you can't plug in the laser because the radar called dibs on the outlet. Meanwhile, Israel wasn't waiting. In October 2024, Israeli forces used early Iron Beam prototypes to intercept roughly 40 Hezbollah drones. $3.50. You cannot get a sandwich for what it costs Israel to vaporize incoming ordnance. The vending machine in the Pentagon lobby is a worse deal. If you're learning something new, consider subscribing. It helps us keep making these videos. But here is the moment this story shifts. Everything I just described, the cost savings, the infinite magazine, the speed of light, all of it depends on one assumption: that you're fighting one threat at a time. A laser has to stay locked on its target for 3 to 5 seconds to cause structural failure. During those seconds, the weapon cannot engage anything else. 3 to 5 seconds doesn't sound like much, unless you're the one drone in a swarm of 30 politely waiting its turn. A missile battery launches multiple interceptors simultaneously. A laser must cue every target and commit seconds to each one. In a saturation attack, those seconds compound. This is why the infinite magazine pitch is misleading. You never run out of ammunition, but you absolutely run out of time. The global response has been to push for more power. Shorter dwell times mean more targets per window. The UK's Dragonfire demonstrated interceptions at $13 per shot. Japan put a 100 kilowatt laser on a test ship. The Navy's Songbo program is targeting 400 kilowatts. Lockheed is scaling toward 500, but every kilowatt added makes the next problem worse. The question everyone asks is, when will lasers be ready? Lasers are ready. They're on ships. They've been used in combat. The real question is, what happens when the weather doesn't cooperate? We built a weapon that moves at the speed of light, costs almost nothing to fire, and never runs out of ammunition. Its only weakness is a cloudy day. That's not an engineering problem. That's a Greek myth. Adaptive optics help. Ion beam uses deformable mirrors that reshape the beam over 1,000 times per second to correct for atmospheric distortion. But in heavy rain, dense fog, or thick smoke, no amount of correction delivers full lethality at range. The beam weakens, dwell time grows, and longer dwell time in a saturation attack is exactly the problem we started with. This is why every serious military treats lasers as complements, not replacements. Israel switches from Iron Beam to Iron Dome when storms roll in. The Navy sees HELIOS as one layer in a defense that still includes missiles and guns. Lasers handle cheap, numerous threats when conditions allow. Missiles handle everything else. The question this leaves unanswered is the one worth arguing about. At what power level do lasers actually replace missiles? Is there a number, 500 kilowatts, a megawatt, where the beam punches through weather and dwell time vanishes? Or is that a threshold physics won't allow? And lasers will always be the sidearm, never the main weapon. Let us know in the comments what you think. Go check out one of our other videos. Remember to like, subscribe, and hit that notification bell. Until the next one, over and out.